Good afternoon, everyone. Welcome to the final webinar in the Sustainable Fleet Technology Series for 2023, Renewable Fuels to Meet Carbon Reduction Goals. Before I turn things over to our speakers for today's session, here are some housekeeping notes for review. This session is being recorded, and a copy of that recording will be made available to you within 48 hours. All participants are muted during this presentation to limit background noise, but we encourage you to ask questions and add comments using the chat or Q&A features. If you experience any technical difficulties during the session, please reach out to NAFA. My name is Quinn. You can message me directly through the chat feature. And now to kick things off, it is my pleasure to introduce Rick Sapienza.
Great, Quinn, thank you, appreciate it. As Quinn said, I'd like to welcome you to our last session for 2023, Renewable Fuels to Meet Carbon Reduction Goals. The point here is, there's a lot of emphasis on electrification, and we're not quite there yet in a lot of areas, but there are ways to reduce your carbon footprint. I'm going to go through some of them today. Do want to have a shout out to our sponsors for this year, some top-notch companies with some solutions to help your fleet with efficiency, alternative fuels, and etc. So if you have a need, reach out to these folks or reach out to me. I can get you in touch, get you some information how they can help you. We do have two upcoming webinars I want to plug at the beginning of the year. We got a product feature webinar from ChemPower, DC fast charging company, and then the Green Garage winners announcement, both that second week in January. And we'll put out registration links and announcements on those shortly. Format, as Quinn said, hold Q&A to the end, submit it to the chat. We're scheduled for 2 to 3:15 p.m. We're going to try and get through our presentations and have the Q&A, get through our presentations about an hour, and Q&A after that. There is a handout that will be sent out as well as the recording to anyone that registered, so you will get this information. Let's say where most of the information is housed that we've done over the last handful of years is on the sustainablefleetexpo.com website. It also has information regarding our conference. We do have a date and an announcement going out later this week. We are going to be at the Durham Convention Center with the Sustainable Fleet Technology Conference for 2024. It's August 13th through the 15th. And today is December 13th, so it's the last one for our Sustainable Fleet Technology webinar series. But on that website, we have registration links when it's appropriate, but we have all the recordings and all the presentations for the last 3 years of everything we've done. Here's my contact information. I am here as a resource. Feel free to reach out to me. I'll help in any way I can or connect you with folks that can help you regarding fleet technology, strategies, and latest trends. And today's speakers, like I said, we are stuffed today. Really, really good lineup. And leading us off will be Arlene Smithson. She's the acting manager of the Climate Economics and Modeling branch, involved in the approval process of pathway petitions to renewable fuels program. She has an engineering doctorate from the University of Michigan and has been with the EPA for 25 years in vehicle testing, certification, and the regulatory side. Our follow-on speaker is Denise Kearns, an environmental professional who advocates for common sense policies based on collaboration, sound science, and good information. Denise is committed to finding solutions to improve supply chain efficiency through better transportation management. She supports the US EPA's Smart Way Transportation Program and is an experienced writer and speaker on environmental, community, and public health issues. She's housed in Ann Arbor, Michigan at the EPA site. Marty Tufte with Waste Management. He's their corporate fleet director with more than 38 years experience with waste management. He currently oversees the equipment for performance programs at the enterprise level. Marty and his team have pioneered waste management's use of alternative fuel vehicles and oversee all new technology programs, including natural gas, renewable natural gas, battery electric, hydrogen, hybrids, and the telematics program. And Marty's going to talk about renewable natural gas today. Next, we'll have Gary Lynch. He's going to talk about renewable diesel. He is the fleet manager for Eugene Water and Electric Board with more than 38 years experience in the fleet industry. His work has been recognized by the industry as a two-time NAFI Flexi Award winner. He's in the Government Fleet Hall of Fame. He's been a Green Fleet Award winner and 10 years running in the 100 Best Fleets. He's also been intimately involved with industry professional organizations. I met Gary a number of years ago and have worked with him through NAFA and the 100 Best Fleets. We have Jennifer Weaver, who saved the day for me, at least. We had a last-minute cancellation on biodiesels, and she was gracious enough to step in with an 11:30 call this morning and is here to talk about biodiesel. She works for Clean Fuels Alliance America as the OEM Market Development Manager. Clean Fuels Alliance America is a nonprofit trade association supporting the benefits of clean energy through industry-leading programs and initiatives representing biodiesel, renewable diesel, and sustainable aviation fuel. She serves as a liaison between the biodiesel and renewable diesel industry and the major auto, engine, and equipment manufacturers. Her work focuses on education on key technical advances in biodiesel and renewable diesel and efforts to support and promote the use of these clean fuels today and in the future. And then rounding out our panel for today is Rick Longobart. Rick is currently the fleet manager for vehicle fleet services at the City of Raleigh. Has nearly 40 years experience in the fleet industry. Most recently, the City of Raleigh was named #1 fleet in the nation in both the large fleet and overall category at GFX. Previously, Rick led the City of Santa Ana fleet to 3rd best overall and #1 midsize fleet in the country and 9th on 100 best and greenest fleets in the nation. He's been a member of MEMA for 29 years and was president for 10 and is a past chair of the NAFA Pacific Southwest chapter. So a really good group here today, and we're going to cover renewable fuels. So next we're going to have Arlene is going to take it. This is our agenda, which I pretty much covered in our intro. So we're going to go right into our presentations. Arlene, you're going to share your screen. I can stop sharing mine. That's the way I want to do it.
Sorry, I'm coming in. I think that I will try to share it, so we'll see that.
Okay, very good.
It's not letting me, so go ahead and do it, you.
All right, we'll go back to me. All right. There we are. Just give me a next one. You're on to your.
Thank you. I appreciate that.
Okay.
So the topic that I'm going to present today is the renewable biofuels regulatory work from the EPA and how that impacts the greenhouse gases. Next. The introduction for our renewable fuel standard program that was created by the Energy Policy Act of 2005, and then also expanded by the Energy Independence and Security Act of 2007. We do the program in consultation with the U.S. Department of Agriculture as well as the Department of Energy. The RFS program is a national policy that require the production of renewable fuels to replace or reduce the quantity of petroleum-based transportation fuel. And there's byproducts like heating oil and jet fuel that are also in the program, but that is not the actual focus of it. The goals for the production of renewable gas by 2025 is 22.33 gallons of renewable fuels annually. And this is a step increase from 2010 when the RFS was started to right now is set to 2025. Next, please. Under the renewable fuel program, there are 4 qualified renewable fuels. They are biomass-based diesel, cellulosic biofuel, advanced biofuel, and we also give a total renewable fuels number that indirectly gives the conventional biofuel standards or regulatory obligation volumes. The program actually obligates parties that are the refiners or the importers of gasoline or diesel fuel. The compliance is achieved to the production or blending of those renewable fuels into the transportation sector, or by obtaining certificates called renewable identification numbers or RINs to meet the EPA specified renewable volume obligations for each year. Please. To qualify, fuels need to be achieving a reduction in greenhouse gas, that means CO2, methane, and N2O of different levels compared to 2005. For the four different fuels categories are 50% life cycle greenhouse gas reductions for biomass, based diesel, 60% reduction or better for life cycle greenhouse gas reduction for cellulosic biofuel. And these are fuels that are produced from cellulose, hemicellulose, or lignin waste. And advanced biofuels need to also be 50% better in terms of life cycle greenhouse gas reduction. And those are fuels that are done with qualified renewable biomass. And then the conventional fuels or renewable fuels, which are mostly cornstar ethanols, have to be better than 20% life cycle greenhouse gas reductions. So my next slide will deal with what is life cycle analysis and how do we have those percentages established. This means that the life cycle analysis is also referred as fuel cycle or well-to-wheel analysis, and that encompasses the upstream emissions associated with the producing of the feedstock that gets in and transportation of that feedstock into the fuel production, then the processing of that fuel in the factory, as well as the downstream emissions associated with the finished product. And the EPA also includes in our life cycle indirect emissions such as land use change for if you are producing, say, vegetable oil, the land that you are increasing to produce those vegetables that will become in oil, all those emissions that are associated with turning that land into production land are what we are calling the land use change emissions. So all those things get into what we call the life cycle emissions analysis of a fuel, and they have to establish 20%, 50, or 60 for the being actually able to meet our specifications for the RFS program. Next. Since we have different pathways, a fuel pathway is really a combination of feedstock production and fuel type. There's right now 21 different pathways that we identify in the RFS. To get a full table, you can go to our website. But basically, we are trying to get things that are either renewable, like vegetable oils, crops, grains, or that are waste, like fat, oil, greases, biogenic waste, and digester waste, biogas, to get into the production of biofuels. Either you get to 50% or 60%, and depending on those kind of things is when we approve the pathway for a supplier or actually a producer of a renewable fuel or a biofuel. Next. So what are the benefits of the RFS program? Well, it promotes the move away from the petroleum-based transportation fuels and creates the availability of renewable fuels for the market. Since the insertion of the RFS, we went from 2.1 billion gallons in 2010 to 9.6 billion gallons by this year of advanced fuels and biofuels. That doesn't count the ethanol, which is established at a set of 15 billion gallons per year. And that's what is the part of the 22.33 billion gallons annually for 2025. But the idea is to move ahead and increase the biofuels and the renewable fuels. We are also with the RFS, setting the life cycle greenhouse gas emission reductions for all those biofuels. As I said, it has to be about 50-60% for the advanced and the renewable ones. And the generation and trading of the green credits provides accountability and cost incentives for the production of renewable biofuels. Also, renewable diesel and renewable gasoline are drop-in fuels that allow for seamless introduction into the fueling systems. And the renewable propane and natural gas have different vehicle and infrastructure needs, but have greater potential for greenhouse gas reduction than gasoline and fuel per se. So next, please. So I'm just talking a little bit more about some tools that we can use for getting greenhouse gas calculations. One of them that is a very simple tool that you can use is the greenhouse gas equivalency calculator from our EPA site. And it converts emissions, or if you have energy data, into what would be things that people can understand as CO2 emissions from cars, households, or power plants. Also, we have other calculators from other agencies, like the heavy-duty vehicle emissions calculator from Argonne National Labs, and that's something that we also use. Next. I just want to mention that alternative fuels locators. This is alternative fuels if you want to get a corridor of fuels that you want to make sure that you have availability through an area. You can find out that there's availability through these different tools. Next. We also have like a local emissions calculator, which is a tool that the EPA put to compile greenhouse gas inventory of entire communities, and is to help local governments operations in particular. And please, next. We also have local emission reduction greenhouse gas programs. In this case, I'm just featuring the Department of Energy Clean Cities Coalition, where there are grants for different cities to improve the greenhouse gas emissions locally. And please, next. And also, I want to feature some of the EPA programs that also help with the greenhouse gas reductions. That is the Clean Ports program, which was introduced with the Inflation Reduction Act of 2022, where EPA is given $3 billion to fund zero emission ports equipment and technology, as well as climate action plans to reduce pollutants in ports. Also, the Clean School Bus Program with the bipartisan infrastructure law provides EPA with $5 billion over 5 years. That's from 2022 to 2026 to replace 16 school buses with zero emission or low emission models. And another program that I want to feature is the Smart Weight program that is improving transportation for freights. And I will give it to Denise Kearns, which is the expert on the SMART program. Thank you.
Great, Eileen, thank you. And the EPA, the DOE, and the Clean Cities, great resources, great tools, a lot of information. Lean on them when you can. They're willing to help.
Thanks.
Denise?
Yeah, hi, thank you. Thanks, Arlene. Again, Denise Kearns. I'm just going to take a few minutes here to look now at another approach that EPA uses to highlight the benefits of alternative fuels through the agency's SmartWay program. I'm joined today by my colleague, Chen Zi. She'll be on hand to answer questions. Chen supports data quality and data analytics for EPA SmartWay. And again, she'll be on hand to answer any technical questions. We can go to the next slide. So in my discussion, I'll give you a brief introduction to SmartWay, and then we'll take a look at how alternative fuels fit into the program and how SmartWay encourages and supports companies that use alternative fuels where it makes sense by highlighting their investment and the benefits that they get by diversifying their fuel mix for their fleets and the opportunities for emission savings. And go to the next slide. I'm not sure how many folks on the call today are familiar with SmartWay. I know that we have Waste Management on the panel today, and Waste Management, of course, has been a longtime SmartWay partner. I think, at least 10 years, partnering with us since 2010, and they have a significant investment in alternative fuels. So thank you, Waste Management, for your leadership. For those of you who aren't familiar with SmartWay, SmartWay is a public-private partnership. We're focused on freight. Registered partners include carriers, as well as logistics and shipper companies that procure freight services. Through SmartWay, EPA works with these companies, our partners, voluntarily. It's a voluntary partnership to collect information on their transportation activities. So an activity-based program with a goal to help them calculate freight's emissions impacts, and that would include NOx, PM, and carbon, and to find ways to reduce those emissions and improve their freight operations. SmartWay is well established. In fact, next year, 2024, will mark SmartWay's 20th anniversary. So for 20 years, the program has provided a standardized approach for its partners and the industry at large to track, monitor, and establish an inventory of an organization's freight emissions year over year. We help raise awareness around the emissions and sustainability benefits of freight efficiency, including alternative fuels use, and we offer a platform for our partners to collaborate. So at the end of the day, SmartWay's goal is to help its partners, that's shippers, carriers, and 3PLs, provide and providers that manage the transportation of materials and goods to save fuel, reduce their transportation costs and emissions. So the program does this by providing partners with tools that will prompt a user to collect and submit information about how they are transporting materials and goods. This data includes, key activity-based data, including information such as the number, the age, the class of the trucks or other assets that a fleet is running, vehicle miles, and of course, the fuel or fuels that a company uses for its transportation operations. Now, the freight industry, as we know, relies almost exclusively. Am I still on camera? Yeah? Did I lose you?
Oh, we're here.
No, okay, sorry.
You're here.
Okay, my computer's been a little funny today. So the industry really relies on petroleum-based diesel as its primary energy source, but a lot of the companies, at least some of the companies that joined SmartWay, they joined because the program's mission, freight efficiency, emission reduction, aligns with their objective, the company's objectives, the partners' objectives to reduce emissions and improve sustainability. So some of these partners, as I mentioned, Waste Management being one, are investing in equipment that can run not only on diesel, but many alternative fuels as well, including CNG, hybrids, propane, biodiesel, and electricity. So let's go to the next slide. Currently, EPA's fleet emission tools can process and apply fuel-specific emissions factors for 6 alternative fuel types that would include CNG, LNG, electricity, hybrid diesel electric trucks, and trucks that run on biodiesel. We have almost 100 partners that use these fuels to operate their trucks. Of course, CNG is by far the most commonly used alternative fuels, with our partners operating well over 20,000 trucks, followed by LNG, biodiesel, propane, and the other electricity is just sort of coming on board, as you said at the top here. It's really just, making a tiny little inroad. So what we're hearing from more and more of our partners about their growing interest and some use at this point of renewable diesel, renewable natural gas, and hybrid equipment that also runs on these alternatives. These drop-in fuels may offer even greater benefits than traditional CNG and other alternate fuels. So we're working with Arlene, other offices in EPA, other agencies to develop emission factors for these alternatives so that fleets can better understand their in-use emission benefits at the tailpipe. So next slide. For now, SmartWay partners receive emission inventories that they can use to see the benefits of using alternative fuels as compared to diesel. Partners also may be recognized for their leadership through our annual awards program. For 2024, we are exploring options for a special award that would recognize partners that are using alt fuels. We also publish a list of high performers, highlighting partners that are operating efficiently based on our carbon-based performance metrics, as well as partners that operate cleaner fleets, cleaner and more efficient based on the program's NOx and PM metrics. In addition, we work with partners to highlight them by developing kind of case studies or partner features that provide some detail on the operational practices they deploy, including fuel diversification as a means to move materials and goods more sustainably, efficiently, with less emissions. Recently, we updated our website to highlight and inform visitors to the website of SmartWay partners, because a lot of shippers and other companies are looking for partners that might be using alternative fuels, including things like natural gas, biofuels, electricity. And again, given the growing interest in more bio-based alternatives like renewable diesel, renewable natural gas, we're exploring other ways to encourage, support, and highlight organizations and companies that are leading the industry through their investments to decarbonize and reduce PM and NOx emissions from transportation and the freight sector. So thanks so much. Look forward to any questions.
Great, Denise, thank you, appreciate it. And we're a Smart Way supporter, and we promote you folks as well.
Great.
Great. So now we're going to go into the end fleet users. Marty Tufte with waste management. I'm going to lead off with renewable natural gas and what they do overall. They have a very large natural gas fleet and they're doing a lot of things. I've had waste management on several times throughout the years, and they know their stuff, and they're just a real good example and great group to learn from. Marty?
Thanks, Rick. Appreciate it. And Denise, if you can hang out, you'll get a new update on where we're at as of today. So I think you'll enjoy it. Appreciate the shout outs. Next slide, Rick. So reasons for RNG, pretty simple for us. Clean air for our customers. As we say, we drop off emissions at everybody's door. So we want to make sure we're doing the right things for the environment and our customers. It's healthier for our people that operate the trucks. We have lower maintenance costs by running natural gas and most specifically RNG. And it has the lowest fuel cost and is the most economical. Next slide. Part of our plan for RNG, as you'll see here today, at the end of 22, we had 6 RNG plants in service at our landfills, producing about 3.7 MMBTUs, and landfill gas used beneficially was about 53%, and we had about 75% running in our fleet. Our goal by 2026, this is a stated goal that has been out there for a few months anyway, is we are in the process of constructing an additional plants, many additional plants, taking us up to 21 plants in service by that time, producing 24 million MMBTUs, raising our landfill beneficial use to 65%, and our stated goal is that we will be at 100% by 2026, and what that means is every gallon of fuel that we burn in our fleet will be produced by one of our landfills. And then at that point, we will have enough volume where we will actually sell RNG and have it available for sale. Next slide. Just a few of the reasons. We started out on CNG back in the late 90s. We did it in California because it was regulatorily required. Another highlight is when we launched Seattle, which was the largest municipal alternative fuel launch in US history. We're with well over 100 trucks that we launched those first back in 2009. I've already spoke to, some of the benefits. Also, our drivers really like it from it's quieter than a diesel perspective. You've got some federal grants out there, and then the environmental benefits are fairly obvious. Next. I really like this slide because there's a lot of people that really don't understand how we do what we do. And this, for me, really takes it and brings it all full circle, or closed loop, as we call it. Dropping off waste at a landfill, we take care of that waste in an environmentally responsible manner. We harvest the methane, clean it up at an RNG facility, which is what we just spoke about earlier on a slide as far as how many of these facilities that we're building. And then we put that back into the pipeline. We establish a pathway, and then that goes back into our trucks. Next slide. These are just some fun facts, and from an environmental services standpoint, what we have to offer. I always throw this in there. The one that's, I'm going to update a couple of these numbers in a later slide, but the biggest one is in the lower left-hand corner, reducing our emissions by 46% against our 2010 baseline, which is, coincidentally what Denise was talking about when we started with SmartWay. Next slide. I spoke to this a little bit earlier. This is our history on natural gas. We started out in the late 90s. I already spoke to what we did in 2009 when we launched in Seattle. Really, the very beginning for us is when we launched 120 natural gas trucks in El Cajon in San Diego. Then in the 2000s, we were about 405 natural gas trucks. Working our way up to 2020, we were at 10,000 plus. We already achieved our 2025 emission reduction goals by then. Next slide, part 2, Rick. And currently our fleet, by the end of this year, at the end of the month, we will be over 12,000 natural gas vehicles running down the road every day. We'll be at 194 fueling stations, which we design, build, own, and operate. We have 28 of those open to the public, along with some other fleet-to-fleet agreements on the other 194. We are planning, we run about 25 new projects a year, give or take, in the year of 22, and we're always a year behind when we're calculating in our sustainability reports, as we burned over 90 million DGE of natural gas, displacing obviously over 90 million diesel gallons. We've invested over $4 billion in trucks and infrastructure since the program began. And then we completed an advanced disposal system acquisition, which is, we are the largest US DOT fleet in alternative fuels. We were the largest US DOT fleet until Knight bought Swift, and now they leapfrogged us again. So we joke back and forth with those guys. Next slide. Here's our RNG usage. You can see, as we've talked about, reducing our fleet emissions and also our carbon intensity. We bumped up just a little bit in the ADS acquisition because they were a predominantly diesel fleet, and we bought thousands of trucks in that acquisition, and we are now in the process of converting them over to natural gas as well. And I'd already talked about the plants that we're in the middle of building, and you can see harvesting that in the lower right-hand corner. Next slide. Our strategy on this is we started with our largest fleets, and we're working our way down, and we are actually deploying natural gas to as small a sites as 10 trucks. We have pioneered the way that we can do that via transporting from parent and child stations and taking, when our trucks are out, collecting and servicing our customers. We are actually producing gas at those facilities, trucking that to the smaller facilities and fueling those trucks at night, thereby utilizing the capital during the day when it's not being used. Next slide. And I believe this is the last slide. We are going to expand our CNG fleet to 18,000 trucks. That's our plan. We'll probably be 300 plus stations. As I talked about earlier, increasing our production to 100% RNG in the collection fleet, and continuing to reduce emissions in the north of the 40% range, with our ever chasing goal of being near zero as an emissions for our fleet. And we do that via, this is the best and the fastest way we do it now. We are certainly technology agnostic. We are looking at all forms of electric. It's just right now, it's pretty difficult in the Class 8 heavy space for electric with weight and cost and things like that. We're also exploring hydrogen and all other types of alternative fuels. But the biggest one for us that makes the best impact and works really well right now is natural gas, obviously. And Rick, I think, is that the last slide?
That is.
Yes, it is. And then hopefully I can hang out for the very end, and if anybody has any questions on that. Appreciate it, Rick. Back to you. Thank you.
Yep. No, Marty, really appreciate it. You know, the refuse industry, natural gas is a really good fit. And over the last 10 years, more than 50% of the new refuse vehicles have been natural gas vehicles. And I think to point out is it's shifted even the last few years. Out on the West Coast in transportation with natural gas, more than 90% of it is renewable natural gas. So you're seeing that environmental benefit. And then across the country, it's over 50% now. And those numbers were, I think it was right around 45 to 50 as recent as 3 or 4 years ago on the West Coast, and below 30%. So we've seen a big pickup in terms of the use and folks generating and capturing methane to use it as renewable natural gas or biogas. And then we go. So next up, continuing our renewable theme for the day, we're going to have Gary Lynch is going to talk about renewable diesel.
Okay, thanks, Rick. So I want to talk a little bit about renewable diesel and kind of how we got there. We are a public utility here in Oregon, and most everything we do is on the West Coast. This is where renewable diesel kind of took our stronghold, and I'm going to be able to talk about it. As I get into this, I want people to kind of remember, I use a lot of terms and weighted averages, and I'll kind of express those as we go. So one of the first things I have renewable diesel, we've actually been on it since September of 2015. So we've got a little over 8 years of history with our operation. But one of the biggest questions I get from a lot of fleets on it is they kind of think renewable diesel is biodiesel. And I just want to take and do a really quick high level and talk about the three products. Rick, want to go to the next slide for me, please? And essentially, I want to back up all the way and we want to talk about petroleum fuels. And really, what petroleum fuels? We take this black cookie stuff. It's, you know, it's a couple million years old. It's literally plants and animals from a long time ago. And we took and we put it and we push it down a pipeline. And this is a very high level refinery process. Obviously, if you ever drove by a refinery, they're very sophisticated. There's a lot of pipes. There's a lot of other projects. But this is just to give you kind of a high level terms of what it is. We push it in. We heat it up, and basically out of that process, we get between alcohol, diesel, jet fuel, gasoline, propane, and a lot of other fuels. Next slide, clerk. So back in, I would say, I think it was 1985, biodiesel, which biodiesel is a great fuel. I don't want to discredit biofuel. It really served everything we did. We've been on biodiesel here for years before we switched over to renewable diesel. But back in the early 90s, it's a different type of process. And this is where we took the material, the plants and animals, and we added different things. And again, this is a high level slide. Basically, out of this in here, we were able to do through our transportation process, we were able to make enough another fuel, which was biodiesel. I had a byproduct of glycerin. One of the things I kind of note in here is when we kind of went in to make biodiesel, we kind of reached in with one thing and to reach out to pull to make something else. It was not a refinery we would see a refinery today. And with that, one of the things we run into was oxygen in the molecules, which kind of gave us some cloud point issues. It gave us a little bit, fungus. And when it first came out, a lot of people were looking at it. There really wasn't a lot of guidelines to it. So when fleets went over and tried this fuel, they kind of got a black eye. But today, biodiesel, it's very refined. It's got standards, the way it's made. The fuels come out. It's a great fuel, and a lot of fleets are doing with it. The only downside with the bios is a lot of fleets really don't run it much about a B20 blend. They kind of blend it in with their diesel fuel. Today, we're seeing it being blended in renewable diesel. So we're not seeing it widely used as a potential it could have. Next slide. So with that, today we kind of got what was called renewable diesel. It's a hydrotreat. And this is where we're taking the plants and animals and the stuff we have from today. I'm just going to call it tallow for sense of purpose. And we actually kind of use that same refinery process. We push it in, we heat it up, we actually interject hydrogen into it, and our output came out with products of what we call renewable diesel. I think Jennifer's going to talk a little bit about renewable aviation fuel and the other byproducts, which really isn't too much you see here on doing it, but the biggest is kind of remember renewable diesel is actually made more of a refinery process and not a process that we make biofuels on. Again, it's made with a lot of the waste animal products, fish products, cooking oil. There's a lot of different things that renewable diesel is made of. In parts of the world, what they like and different things, availability is the output. The thing you got to kind of remember on here is the output of it basically has a different value. And we're going to talk a little bit about CI values here in a little bit. Next slide, Rick. So one of the things I want to talk about is basically, and this is between all fuels, and you can go ahead and hit all the bullets for me there if you would. The thing is to kind of remember what goes into a gallon of alternatives. And obviously we have feedstocks. The thing is renewable fuels, it kind of drives the price and makes it up there. It's fairly new. It costs a lot of money to make these plants that made like ethanol and made biodiesel. Obviously, a refinery, what a refinery would cost today. So the refining cost is actually considerably higher than what we had compared to the base stocks of gasoline and diesel. Our distribution cost tends to be higher, and that's mainly because there's only so many places that make the product, and we have a longer distance to be able to take it to the end user. So the distribution costs are considerable. And then taxes. Taxes obviously vary from state to state. Again, this is a slide we put together a couple of years ago. We worked with Clean Cities, and we just try to put together kind of demonstrate what goes into a gallon of fuel. And again, the thing is, if we want to be able to get the fuel and get the prices over all in there, we need to use more products so they're able to produce it and put it out. Next slide. So speaking of costs, this is where I want to kind of come back and talk about. We've been on renewable diesel for over 8 years. This is our historic cost that we used it. Now you see a sign up there. It says average price per gallon. It says GALSI. What GALSI is basically a cooperative purchasing we put together by EWEB. I only go through 90,000 gallons a year of renewable diesel. So when I was asking for renewable diesel, when we started on here, it was, yeah, right, who are you on doing it? So together, we got together with the cities, the counties, the school districts, the transportation groups, and we kind of reached around a couple of counties, and we formed our own cooperative purchasing. And when we came back and we put all our purchasing power together, now we're going out for a contract renewable diesel that's close to 7 million gallons a year. And that's how we got the attention. We actually started GALSI back in the late part of 2017, but if you kind of see the prices of fuel, as the fuel got in there, it was extremely going to attract the cost of regular fuel. It was fairly easy to get, and we were able to do it. We talked about it, and then the supply chain kind of got, well, we had kind of create our own shortage just because everybody wanted it. But as we got along and these clean fuel programs took effect, you kind of see where the prices for renewable diesel have backed down. Next slide. And basically, we're going to talk a little bit about maintenance. I want you to go ahead onto it. This is a slide surprised by Nestle. It's actually fairly old, but it tells the story on here. And you're going to see two different burns on here. The one is actually on the left side is renewable diesel, and the one on the right side is regular fossil fuel. And what you see in the air there is soot. That's bottom line. It's what goes out our exhaust systems and starts filling up our catalyst. So we get into the maintenance of our vehicles. Slide. Next slide, Rick. There we go. So we talk about some reduced maintenance and some of the effects that we actually get from running renewable diesel, because it is a burning or cleaner burning fuel. Now, some fleets will out here will say, yeah, reduce, we have no more regens and everything else. We've been on 8 years. We got a pretty good track record of it. We still have a few gen rates, but I don't gens like we used to. We're not having to send people, and we don't get to check engine lights. We do have some on some vehicles that you literally don't drive enough or get hot enough to be able to kind of burn it out. And so our DPS do tend to plug up from time to time, but we're a smaller fleet here, but I probably don't do a regen maybe once every other month on our fleet. I have never replaced a DPF related to being plugged up. I've had to replace a couple because of damage internally from something else, but we've been on renewable diesel, and it's just something we don't do. We don't clean, our maintenance program, we don't have it. Our fuel systems, we've been actually able to take our fuel systems. We don't replace the fuel filter now in our systems, that we've had this in there for a couple of cycles, basically when it comes in for a PM, just mainly because it's a really clean fuel. I don't have insurance issues. We don't have the maintenance that's on the backside. But one of the biggest things we found by running renewable diesel, we have an in-house oil analyzer. So we have our own lab. So when mechanics come in and they're working on a vehicle, they actually come in and run oil analysis on here. We find that the oil itself is cleaner. Again, it's the soot level that we find in almost kind of where it is, where the additives and stuff are at. So we're actually able to extend our life cycles on our vehicles to every 2 to 3 PM cycles before we actually do a drop. So there are some benefits of running a clean fuel. We call it a synthetic fuel. People call it other different things, but there are benefits to running this type of fuel. Next slide. Okay. This is, again, I'm going to use weighted averages. This comes from the state of Oregon, and run in different types of fuel. Excuse me. If I'm running B5, essentially I'm going to reduce our emissions about 3.1%. In Oregon, running B20, and again, its weighted averages reduces emissions around 12.4%. Now, again, on a weighted average, this takes everything. So all the different products let's make it. Now I can have used cooking oil and make it, I'm going to have a higher emission reduction. But this is using the weighted averages. Using RD50, which is renewable diesel, you're going to see reduce emissions about 31%, and using R99 reduces emissions about 62.3%. The state of Oregon, again, on average. Next slide. One of the things that I talk to a lot of fleets on is basically, what does it take to reduce 1 metric ton of emissions? So I'm going to kind of run through a little bit of a scenario here. Let's take a vehicle, just hypothetically put something together here, a class 2 through 6 vehicle, diesel engine, driving around 14,000 miles a year. Basically, the estimated useful life, a 10-year cycle. And let's say you're paying $3.80 a gallon. Now, I know throughout the country, diesel prices are all different. California, Oregon, West Coast tends higher, back east it's a little bit lower. But I think you're going to find, again, we're going to use some weighted average. You're going to see the difference here. Next slide. So I'm going to take a basic unit, and let's say it gets 15.5 miles a gallon. Okay. Over the life of that 10 years, I'm going to use 921 gallons. Annually, or 9,200 gallons over the life. At a cost of $3.80, I'm going to pay about $3,500 a year for fuel. 35,000 over 10 years. And my annual emissions will be about 12.48 tons or 124 of the 10 years. If I took a vehicle and I has a hybrid option, they're using them out there. There's a lot of vehicles, a lot of options out there. But if someone would come back in and said, here's an option on a vehicle, and it's going to get 25% better fuel economy than you're getting right now to replace this vehicle, and let's say that costs you $18,000, you're going to reduce your fuel. You're only going to go through 937 gallons annually. Your fuel cost drops down to actually 2,800, I missed a decimal on that, and your actual emissions up on the 9.68. If we turn around and took that cost of that 1,800 plus, put your fuel cost together on here, what did it cost to reduce 1 metric ton of diesel or of CO2 emissions by using this particular option or regular diesel fuels? $440. Basic cost of it. If you were to switch over and just put in R99 renewable diesel, you're going to go through the same amount of gallons. We've been on it long enough. People say they get better fuel economy. No, we get the same thing. It's diesel fuel. It doesn't get any better fuel economy, you know, than regular fuel on here. My fuel cost, and I'm going to up the fuel cost on this about 60 cents because on the West Coast we got some some programs out here, the clean fuels programs, which actually increase some of our fuel costs or reduce them for us for use possibly on the East Coast. Taking that 60 cents a gallon and adding to the fuel, your actual emissions come down there is about 4.71. So the annual cost to reduce them is basically $71 to reduce 1 metric ton. Slide. Okay. My computer just timed out. I had to come back in. Okay. So essentially, you know, when it comes to looking at fossil fuels versus CO2 emissions, you know, what does it take? What it is? Sometimes in our fleets, we don't think twice about purging the vehicle that costs another $18,000 more. But when it comes to running an alternative fuel on here, we balk it if a gallon, if it's 5 cents a gallon, 10 cents a gallon more. And then more than anything else, we need to look at every project we do, whatever vehicle we get, and we need to kind of remember our mindset, and we need to go back and we look at what does it cost to reduce 1 metric ton of emissions. Doesn't matter what fuel it is we're looking at the end of the day, what does it cost to do it? I love the slide from Waste Management. They're doing a great job. Their probably cost to reduce metric ton on it's probably a negative number. They're probably making money on that through the bank. Again, it's your best buck. So running renewable diesel. Next slide. This is our summary. This was all the way up to December 1st. This is a really simple calculator, kind of show you. Again, we run a lot of different fuels in our organization. We have a baseline that basically is if I was running regular gasoline or diesel, and then you can see we run E10, E20, and E85, all great fuel. We run B5. I'm not running too much on the B20 right now, but we are run 99. And by being able to put a calculator again based on carbon intensity values, and again, this is weighted average on here, we've been able to reduce ton emissions 933. Essentially, it's a 40% reduction in emissions. Gives me a percent of alternative fuel use of about 62%. At the end of the day, what did it cost me? Almost 2 cents a gallon. So what did it cost to reduce 1 metric ton? It's about $3.68. These calculators are out there. There's a lot of great ones out there. Sometimes really down dirty and simple calculators make a lot of sense. Next slide. Yeah, and that's pretty much it. There's a lot of stuff about renewable diesel. You got a great speaker coming up that's going to talk about it and a little bit more about it. But for us, it's been a great fuel. Trying to think of what I kind of missed in here. You know, you can run it straight, you can blend it. Bottom line, it meets diesel fuel. It meets the same standard, meets the same carb standards. It's stable. You can store it for a long period of time if it's in your underground storage tanks at an R99 value. Depending on where it's produced at, it actually gets the cloud points. You're seeing it get down to the really cold temperatures, and some aspects outperforms the regular diesel. And it's a renewable fuel. There's a lot there in respect to the other speakers' time, so I'm going to turn it over to them.
Great,
And I'll be
Gary.
around for questions on the end.
No, thank you. You know, Gary's been a long time user R99. Like he said, they started the program back in 2015. And so he's got a lot of data and a lot of experience with it. Thank you, Gary. And next up is, like I said, my savior for the day, Jennifer Weaver. Really appreciate you stepping in here, and we'll let you take over from here.
Absolutely. Well, thank you for the invitation, and really wanted to commend the speakers that have preceded me here. You've set up my comments well, so I can speed through a couple of things here. So next slide, please, Rick. I did want to start kind of with a different way of looking at this topic that we are discussing here today. You know, there's a lot of great options that we are evaluating in terms of how do we reduce greenhouse gas emissions. But I kind of wanted to refocus us on why that's important and other things we need to think about. And it has to do with a concept called the time value of carbon. So as we are evaluating these different emission reduction strategies, different fuels and technologies, there's really two things that we need to consider. And one is the amount of reduction that we're making in carbon and other greenhouse gas emissions, but also when it happens. And that is because these carbon emissions are persistent. They don't just go up in the atmosphere and dissipate. They accumulate, they stack on top of each other, and they persist for decades, if not more. And these increased levels of carbon dioxide in the atmosphere are contributing then to global warming, not only now, but for decades to come. Conversely, if we can make significant reductions in CO2 emissions now, that can help us avoid decades of associated heating and then having considerably more impact on carbon reductions that we can make now versus those that are made 5, 10, 15 years down the line. So in other words, the time value of carbon is key. And this next decade is really critical as we are doing everything in our collective power here to try to keep our global temperature from rising any further. Next slide, please. So the good news is we have a very easy way to decarbonize that is available now, and advanced biofuels. My friends at EPA discussed this a little bit earlier about the definitions of advanced biofuels, but basically OEMs and fleets are taking a fresh look at advanced biofuels, including biodiesel and renewable diesel, as better, cleaner, advanced biofuels that are available now for them to use in their existing diesel engines, allowing them to make some immediate reductions in carbon emissions easily and affordably. As mentioned previously, advanced biofuels are categorized as those that reduce greenhouse gas emissions by at least 50% compared to diesel fuel. And in fact, B100 pure biodiesel reduces greenhouse gas emissions by more than 70% on average compared to ULSD. And depending on the feedstock used to make that fuel, it can be upwards of 90% or better in biogenic carbon reductions with B100. Next slide, please. Another way to look at this time value of carbon and to consider the importance of doing something sooner versus later. For every 5 years that we delay and continue on as business as usual, just using regular diesel fuel, we will have to reduce emissions 13 times more in order to have the same climate impact. So in other words, you know, again, reducing these CO2 emissions today can avoid decades, even centuries of associated heating. So the green line there represents the emissions levels using clean fuels, biodiesel and renewable diesel. The orange line represents the significantly higher carbon emissions in using petroleum-based diesel. So again, doing something sooner versus later makes a huge impact for the planet. Next slide, please. My preceding speaker did a great job of outlining some of the production technologies with biodiesel and renewable diesel. I won't go through all of this in detail, but just wanted to point out some of the similarities and differences in biodiesel and renewable diesel. Again, Clean Fuels Alliance America is the trade association for both biodiesel, renewable diesel, and sustainable aviation fuel. So both the fuels are low carbon diesel replacement fuels produced from the same types of feedstocks. So used cooking oil, byproducts of the meat processing industry, animal fats, variety of vegetable oils, soybean oil being the most prevalent, inedible corn oil, canola oil, and others. The thing that differentiates them, I guess, is the production process. Again, as mentioned previously, biodiesel is produced through a transesterification process, pretty simple, straightforward process that produces a fuel that meets the standard called ASTM D6751, the specification for B100. Renewable diesel is produced through a slightly more energy intensive process, more similar to the way typical petroleum is refined, called hydrotreating. It goes through an additional step called isomerization and distillation to produce a fuel that is chemically pretty much indistinguishable from diesel fuel, meets that ASTM D975 diesel fuel spec. Both of the fuels are considered drop-in replacements for diesel fuel, can be used in any piece of diesel engine or equipment. Biodiesel side tends to be used in blends up to B20. However, as I'll be talking about further here in the next couple of slides, we are seeing trends toward increasing blends, and several manufacturers already do support up to B100 as well. Renewable diesel typically can be used in blends with biodiesel or petroleum diesel, but also can be used in a pure form, dropped in at 100%. Both fuels, ultra low sulfur, biodiesel on its side, non-toxic, biodegradable, 0% aromatics. Both of the fuels are good for engines and provide improved cetane. Biodiesel has the additional benefit of increased lubricity. So it will certainly help to keep your engine running smoothly, replaces the need for any kind of a lubricity additive to your fuel, one of the great benefits of biodiesel. And I mentioned those ASTM fuel quality specifications for biodiesel and various blends there, as you can see. Also in blends up to B5, just meets the D975 diesel fuel spec. All right, next slide, please. I would say another thing that distinguishes biodiesel and renewable diesel is just its geographic availability, to be frank. So pretty much every drop of renewable diesel that is being produced today is working its way out to the West Coast. So they are fortunate in the state of Oregon and Washington and California to have some access to it. But otherwise, it is still fairly hard to come by. And the reason that most of it is going out to the West Coast is because of the availability of low carbon fuel standard policies that are helping to bring the cost of renewable diesel more in line with diesel fuel. In other markets outside the West Coast, renewable diesel does run at a premium to diesel fuel, upward of $1 or more per gallon, because of that more intense production process and the processing charges to do that. However, biodiesel tends to be much more cost effective, running on par with, if not less expensive than diesel fuel, and is available all across the United States. So that is why, majority of fleets have access to and are tending to use biodiesel, just, because of that availability and the cost benefit of it. However, we are starting to see some fleets that do have access to both biodiesel and renewable diesel, using them in blends, and together they make an exceptional fuel. You can kind of see here some of the emissions benefits that you can get by blending either B20 and R80 or B50 and R50. I would expect to see that as the volume of renewable diesel continues to grow and build, which we are seeing happening in the industry, and hopefully as some state policies evolve to help bring low carbon fuel standard like programs to other parts of the country, we will start to see more of these blends of the fuel being used across the country. Next slide, please. Well, Rick, I don't know if you planned the timing of this webinar today this way or not, but if any of you were paying attention to the news headlines earlier today, the switch to renewable energy is definitely top of mind. So in the COP28 meetings that have been taking place in Dubai this week, today they announced in a first that nearly 200 nations have agreed to move away from fossil fuels. And note the headline here today in the New York Times: for the first time since nations began meeting 3 decades ago to confront climate change, diplomats at COP28 today approved a milestone plan to ramp up renewable energy and transition away from coal, oil, and gas. So big changes are afoot in the fuel industry. And as we've all been talking about here today, carbon reduction is now driving that market. And as we also discussed before, B20 is simply not enough for many policy targets and corporate, environmental, social, and governance goals. We are hearing from industry, from the fleets that we work with, that B20 is going to be the minimum that they use in on and off-road engines. They're moving toward B30, B50, even B100. And the heating oil side of things, that also is transitioning to B50 and B100 as opposed to traditional heating oil. Marine applications want to be using B50 and B100. Railroads want to be using over B20. And there's also interest in low carbon electrical generation. So you can kind of see a lot of these categories of equipment are medium heavy duty vehicles, off-road equipment, sustainable aviation fuel, as we mentioned before. These are segments that are extremely hard, if not impossible, to electrify. They required long haul, heavy loads, very intense duty cycles that just make EV options really not applicable or viable for them at this point. And this is really a great opportunity for biodiesel and renewable diesel to come in and make a big difference. Next slide, please. I wanted to make you all aware of a really helpful resource that we have available for you. You can scan the QR code there and go right to it to get a summary of the various OEM positions of support for biodiesel and renewable diesel. It's available on our cleanfuels.org website in our toolkit. I do want to make a note that biodiesel is registered as a legal fuel and a fuel additive at any concentration. The vast majority of new diesel engines in the on-road and off-road space now have full support for at least B20 or higher blends, meeting again those ASTM standards that I mentioned before. And many OEMs are also recommending that biodiesel be sourced from a BQ 9000 certified supplier. And that is our industry quality control program for biodiesel producers, marketers, retailers, and laboratories. And over 90% of the biodiesel in the US marketplace today is produced by a BQ 9000 certified supplier. So again, check out that toolkit there for links to all of the major OEMs positions on these two fuels. Next slide, please. I can tell you, after working with this industry for over 20 years and working for our technical director and senior technical advisor, there has been a lot of effort gone into ensuring nothing but the highest quality biodiesel makes its way into the marketplace. We have increasingly stringent ASTM specs for the fuel. Again, that BQ 9000 program that I mentioned that have virtually eliminated issues that previously were attributed to biodiesel in its early days. Evolving sets of these specifications now have resulted in biodiesel that has ultra low metals, which is good for the new ultra low emissions diesel engine technology that's coming out. Very high oxidation reserve or stability value for the fuel, anywhere from 1 to 3 years, as opposed to previous 6 months or less kind of advice that used to be the rule of thumb. Very low minor components, things that can be bad actors in cold weather. We have a number 1B grade, low metals grade of biodiesel, exceptionally good for cold weather operation. So my tips for success for fleets that might be tuning in is make sure you're requiring ASTM grade fuels when you're speccing your fuel. Buy from BQ 9000 quality or Q 9000 certified suppliers, which are easy to come by as well. And be proactive with your cold flow management in the winter months, or use the Optimus system. And I wanted to give a quick shout out to them. Next slide, please, Rick. So our friends at the City of Madison that had intended and hoped to join today, unfortunately couldn't due to some health issues. They are joined in good company by a lot of other fleets, some of which are pictured here: Washington, D.C., Star Oil Co., the City of Madison, as I mentioned, City of Ames, PepsiCo, and Frito-Lay operations. All have something in common, and that is they are using B100 in its pure form with something called the Optimus system, which is basically a dual tank system that is allowing vehicles to start and stop on diesel fuel. Once the engine warms up, switches automatically over to B100, runs the entire duty cycle on B100, again, maximizing that carbon reduction by over 90%. So definitely an excellent option, especially in companies that have heavy duty operations, as are pictured here, may not have access to renewable diesel. but want to do the maximum that they can to drastically reduce their carbon footprint. Excellent application for medium and heavy duty options. Next slide, please. Just wanted to close out with my contact information there. Happy to answer questions at the end, and certainly encourage you all to join us at the Clean Fuels Conference in February in Fort Worth, February 5th through the 8th, to learn all there is to know about biodiesel, renewable diesel, and sustainable aviation fuel. Thank you.
Great. Jennifer, I appreciate you stepping in today and great information.
Thank you.
All right, we're gonna quickly jump to the city of Raleigh with Rick Longobart, and he's gonna talk about some of their alternative renewable sources across, but then finish up with renewable propane.
Yeah, thank you, Rick, and thank you all for joining us today. Good afternoon to you, everyone, wherever you may be. A great presentation, Jennifer, and all our colleagues. Great information shared. I think I'm probably going to echo a lot of those sentiments and share a little bit about what's already been covered. But Rick, before I get started, just want to do a checkpoint. I know it's 10 after 3. How much time do I have? Because I'm sure there are a litany of questions that you probably want to cover.
We have a good handful of questions. I mean, I apologize. I knew we were stuffed today, and I didn't want to cut anybody off because it's been some very, very good information. Do the best you can. I told you keep it under 10. If you do better than that, do it.
All right, I'll get extra credits. I think I could probably wrap this up in about 5 to 8 minutes.
All right.
So next slide, Rick, if you don't mind.
All right.
So much like everyone else talked about, the city of Raleigh is aggressively moving towards a more sustainability environment. Just to share a little bit about our statistics, a little bit about our operation. I won't go into reading out these statistics, but we're a very, very large, diverse fleet. We're a full service operation, anywhere from turf equipment all the way up to fire engines. We consist of about 4,600 plus vehicles. We have 78 staff and a litany of fuel sites throughout the city, just to kind of put texture to the conversation. Next slide, please. We operate out of 3 different facilities throughout the city, so it makes for a very diverse, centralized operation. Next slide, Rick, if you don't mind. We have over 7 fuel sites throughout the city, consisting of a variety of fuel types. And if you move to the next slide, it'll probably save a little bit of time and share a little bit about our operation. We have 7 fuel sites throughout the city, of a complex of a variety of different fuel types, of a variety of different fuel vessels, including propane, CNG, LNG, CNG, gasoline, diesel, biofuel, E85. Just a snapshot of what our fuel sites look like. On the far right, we'll talk a little bit about renewable propane and some of the functions and exposures that we've done to accent the industry and promote the cause. Next slide, Rick, if you don't mind. Much like we talked about, we are a diverse fleet. We do everything we can to touch and reduce our carbon footprint and reduce our dependency on foreign oil, fossil fuels, and reduce our carbon footprint. I need to update one of these slides. That is propane. Our renewable propane numbers are up to close to 100 renewable propane vehicles. But you can see we also do CNG, hybrid, electric, biofuel, ethanol, plug-in electric, and we have some other alternative fuels as well. We are building to anaerobic digester, and we will be moving to RNG as well. And to the credit of the speakers as well, we also believe that there's bridge technologies that can be easily adopted. We're a big advocate of electrification, and our plans are to transition our fleet to 100% electric in the next 10 years by transitioning over 2,200 vehicles to electrification. However, having said that, that's over the course of the next 10 years. So we certainly don't want to be using fossil fuels during that transitional period. So we recognize that bridge technology is easy to adopt, relatively low expensive infrastructure, and can certainly immediately reduce your carbon footprint. So those fleets that are out there and transitioning and looking at ways of reducing costs, you've had some great speakers before me that can testify how easily they've done it with very little effort and very little infrastructure, opposed to some of the complexity that is required to moving towards electrification with charging infrastructure and training and other expensive vehicles that currently may not be available to your market at this point in time. Next slide, Rick, please. Just a little bit about some of the statistics. Again, we don't have a big hole in the renewable propane, but you can see just in 2019, between the 2021, we've advanced our cause Obviously, COVID in 2020 obviously flatlined a little bit about our use of propane, but you can see a few different numbers that is starting to accelerate the cause in propane. Next slide, Rick, if you don't mind, just to change some of the time, save some time here. You can see some of the advancements that we've recognized between 2019 and 2021, some of the carbon footprint that I think some of our other speakers have talked about, just in reducing our carbon emission reductions annually, 64 metric tons in just propane renewable alone, not to mention some of the other fuel types that we're using. So it has a huge impact of our carbon footprint and carbon metric tons. If you don't mind, to the next slide, please. This is our campaign. This is what we're moving towards and already have done in 2023. This is our renewable propane site, one of three. We have 3 propane sites throughout the city. This was a ribbon cutting ceremony that we had a few months ago, where we are now transitioning from conventional propane to renewable propane, which is an animal stock vegetable product. It's not a petroleum-based fuel at all. So we are now carbon zero emission when it comes to propane, because we are running strictly renewable propane at all our vessels. This is a snapshot of our recent ribbon cutting ceremony. You can see the vessel on the upper right-hand side. That is an 18,000 gallon vessel. So we have a lot of fuel available to us. You can see a picture of the dispenser. What have we done to transition from conventional propane to renewable propane for our vehicles and our infrastructure? Nothing. We changed nothing, right? We simply picked up the phone, made a phone call to our propane providers and said, we want to transition to renewable propane. All we did. We didn't have to change any vehicles. We didn't have to change our infrastructure. We simply picked up the phone and made a call. That's how simple it was. And the carbon reduction is amazing. So if you change the next slide, you can see some anecdotal facts. I think Marty shared a little bit of fun facts. Here are some others. I'm not going to read all these for the sake of time, but you can see the carbon footprint reduction if you put it in a picture that kind of hits home, right? Just between 2019 and 2023, in 2019 usage, charging 3,863,000 smartphones is what it relates to, just from our carbon reduction, just on renewable propane alone. But we can power up 6.2 homes in 1 year. We can drive 80,000 miles. We save 3,000 gallons of oil, right? Equivalency to planting trees and acreage. Same thing holds true in 2021 and continues to accelerate as we continue to move our cause. As you can see, the numbers just dramatically increase by doing nothing other than dropping renewable propane into a tank. It's very easily done. If you don't have propane already, you can almost get an infrastructure at no cost, and you're just simply paying for the throughput by going through a propane provider. Very little infrastructure, very low demand for powering up an infrastructure. It's easy to do. All of our sites and all of our fuel types, whether it's CNG, propane, E85, ethanol, CNG, LNG, is all integrated with our fuel management system, so we can calculate exactly the throughput of each site. And so you can see, just by painting a picture of the equivalency, not only the carbon metric tons, but what it means to society and the environment as a whole. Next slide, Rick, please, if you don't mind. We do our own propane installations. This is, again, up to your business model. There's some that have this outsourced. We chose to insource it ourselves because we feel we have a better span of control. It's a simple conversion. We simply buy the kit. We install the kit ourselves. It goes where the fuel tank once was. It's a simple installation. We complete each kit in about 2 hours, 2 hours plus or thereabouts. So it's not a very lengthy installation. If you move to the next slide, Rick, you'll kind of see a little bit in action. It's a very simple installation. The cost is around $8,000 to $10,000 per kit. And again, this is transitioning a conventional gasoline vehicle to propane. And a lot of our kits, if you move to the next slide, Rick, if you don't mind, are paid through grants that we've applied for. These are just a litany of different grants that we've applied for over the years. A lot of the The kits have been paid through the CFAT that's available in the South, in the Carolina regions. But there's a litany of everywhere from VW settlement funds to DARA grant funds. So if you're not pursuing grants, I highly encourage you to do so. A lot of our infrastructure, our kits are paid through grants and not out of general fund money. Next slide, Rick, if you don't mind. And just a shameless plug, Rick, and I think I probably saved us some time and done all this in less than 5 minutes. So I just wanted to thank you, Rick, for the shameless plug. In 2023, we were recognized as the #1 fleet in the nation, not only the #1 largest fleet, but the #1 overall fleet in the country. We're really proud of that. And so thanks to our colleagues that have been on the call and all the information that we've shared along the way have proven to their success. So I want to thank everyone for your time today. The next slide has my contact information, and I will leave it to you, Rick, to go through questions and answers.
Great, Rick, thank you, and I appreciate it. I mean, good demonstration. Gary talked about how he used multiple fuels, and use what works where it works. I mean, if you put something in the wrong application, it's going to be a nightmare. And the mantra of it's an all of the above approach, and then it's been reiterated more than once today. Let's do what we can do today. Everything we presented today is out there being used across the country to help reduce carbon footprint and a number of cases, driving efficiency, saving money, et cetera. So this is a here and now, and we had quite a few. I do have one more quick that I'm going to go through. It was mentioned by our friends at the EPA, renewable gasoline, known as green gasoline or drop-in gasoline. It is chemically identical to petroleum gasoline, meets the ASTM standard, no modifications, no special measures to your vehicle's infrastructure. It's a variety of feedstocks. There's a couple of different ways to do it: biological, thermal, chemical process. And then two that I want to talk about is, the carbon reduction in emissions. California Energy Commission states, depending upon the feedstock, between 61 and 83% reduction in life cycle carbon dioxide. And then Chevron, just a road trip with 3 Toyota vehicles from Mississippi to Texas, 1,000 miles. They used a renewable gasoline blend of greater than 50% renewable, and they showed more than a 40% reduction compared to traditional gasoline. Not a whole lot of folks are using it. It seems to be maybe difficult to get. The city of Seattle signed a 4-year contract. We had them on a couple of years ago. They talked about it with some of their other fuels. But here are some of the producers I came up with. Gevo is the company that Seattle signed the 4-year contract. Chevron, ExxonMobil, Novozymes were other folks as I did research. And here's the 2 links that give you those. The lower one is Chevron. It talks about it was a news release on their road trip, and then the California Energy Commission and their statement regarding renewable gasoline as well. So I wanted to round that out with that, and we can go to. I really appreciate the folks there. We are over, but we do have a few questions I'd like to try and run through. I appreciate everybody hanging in there. And there's somebody looking for simplest GHG emissions reduction calculator, renewable diesel versus conventional. Is somebody from EPA still out there? I'll stop my share and see who's still here in my panel.
I'm with the SmartWay program, and our SmartWay program would provide carrier with tools to calculate the difference between conventional diesel and biodiesel. Currently, not exactly for renewable diesel, which is an aspect that, as Denise has mentioned, we'll be looking into. But right now, our tool is able to compare the difference between regular diesel and biodiesel. So I'll link, I'll get the name from the individual and share our tool, which can be downloaded from our SmartWay website. The carrier tool, I would not say that it's the most simple calculator. You just dial in the number. You have to input a variety of numbers.
And I think A-Fleet, the new update should be able to handle that as well. A-Fleet's downloadable with some DOE. There's an online version and there's a downloadable. It's a very extensive spreadsheet with a lot of information in it. There's that one. Who was this question? Okay, that was just actually most of the stuff were comments and thanking us. So I'm gonna stop running over here and cut us short. I really appreciate everybody. Great information. The presentations and the recording will be available to everybody that registered. And thank everybody for joining me, audience, as well as our panelists. Great job out there, and can't do it without you. So
Yeah,
have a good day, all.
Yeah,
Thank
on
you, Rick.
behalf of NAFTA, thank you all to all the presenters and the attendees for today's session. If you have any other questions that you didn't have a chance to ask, please email events@nafa.org and we will send it along to the correct people. This concludes the webinar. Thanks, everyone.
All right.
Thank you.
Good day.
Rick. Have a good
Bye.
rest of the day. Thank you.